Today, okay, what we're going to go through is we're going to go through trigonometry, which, as you should know, is on paper 2 of the Leaving Cert exam. In terms of trigonometry, you will be asked questions to do with Pythagoras' theorem, using your sine, cos and tan ratios, asked questions to find the area of a triangle, asked questions that will involve your use of the sine rule, the cosine rule. You could be asked to find the area of a sector or the length of an arc. Okay, so in terms of trigonometry, we'll start off with the basics. For trigonometry, what you have to ask yourself is, do you have a triangle? If you do not have a triangle, you are not doing trigonometry, right? But if you do have a triangle, yes, you should be focusing your ideas on trigonometry and trying to solve your question. So, in terms of your triangle, what type of triangle is it? And in terms of your triangles, I'm not asking you isosceles or equilateral or scalene. I'm asking you whether it is a right angle triangle or not a right angle triangle. Okay, so in terms of your right angle triangles, how you will know that your right angle triangle is in fact a right angle triangle is they will have it drawn and they will either have the symbol for the 90 degrees in the corner of one of the angles, or they will have told you that one of the corners was 90 degrees, or they will have used the fact that you have horizontal ground and vertical poles, right? Or level ground and vertical poles. Okay, if you have a right angle triangle, it makes your steps to doing trigonometry a little bit easier. Right, so in terms of a right angle triangle, first thing you have to do is identify the sides and the corresponding angles. So in terms of identifying the sides, you will have your right angle triangle. You have your symbol, so you know that this is the 90 degrees. The side that is across from your 90 degrees angle and not touching this angle will always be known as your hypothesis. Okay? And your hypothesis is very, very important in terms of using your ratios or Pythagoras' theorem correctly. If you're using Pythagoras' theorem, the length of your hypothesis, so h squared, the length of it, so straight lines of it, the length of the hypothesis squared is equal to the length of the other side squared plus the other side squared. And it doesn't matter which order these two come in, they are the sides that are attached to the 90 degrees. Right, so in terms of Pythagoras, the hypothesis has to be the one on its own, looking for the equal sign. So if I jump to the book, okay, so if you have text and test, this is page 393 and there's some triangles drawn. For each of these triangles, okay, they have the little symbol saying it's 90 degrees. Okay, so what I was saying is identify your side. So in terms of this, here's our 90. So the side that is missing is the hypothesis. Okay, in this one, here's our 90, but this time we're given the hypothesis. Okay, 90 and you're missing your hypothesis, 90 and you're given it. So how you solve these will vary slightly. So if I go back to my book for a sec, if we're looking at the first one there, so the first one there is the right angle triangle. The hypothesis is labelled A. Your other sides are labelled 3 and 2. Okay, so I've just drawn that out there. So we have our right angle triangle, how we know because of the symbol, right? The side across from the right angle is the hypothesis. So A is equal to your hypothesis. If you were doing Pythagoras' theorem, you're going hypo, or your hypothesis squared, the length of it is equal to the other and the other. So in terms of this, a squared is equal to 3 squared plus 2 squared. Or you could have written 2 squared plus 3 squared, it doesn't matter. So a squared is equal to 9 plus 4. So a is equal to 9 and 4, which is 13. So a is equal to the square root of 13. And that was because the side we're looking for is the hypothesis. If you look at this one, right, so we have our right angle triangle, and this time we have an 11 and a 6 and a b. So we have an 11, we have a 6, and we have a b. We have a right angle symbol. What you are meant to note is this time the hypothesis is given. So 11 is our hypothesis. So in terms of plugging it into here, you will go 11 squared equals one of the others. So 6 squared plus your b squared. So 11 squared will give you 121. 6 squared gives you 36. And b squared is still we don't know. So you're basically told 121 is equal to 36 plus some number squared. So that means 121 take away 36 is equal to our missing side's length squared. So if we go 121 take away 36, we get 85. So 85 is equal to our missing side squared. So the square root of 85 isn't a nice number. So you could write it down as b is your square root of 85, or you could have gone b is equal to 9.219. Okay, but that's how you solve Pythagoras' theorem. You match your sides of the triangle. You only use Pythagoras' theorem if it is a right angle triangle and you have been given two sides. Okay, but just make sure you match the right way round. If you have your test and textbook, please practice the questions on page 393 and the slightly trickier ones on page 394.